We are given a function, f of x, equals 1 over x plus 1 for x not equal to negative 1. Now let's consider two different cases. Case 1. We are given the function h of x equals g of x over x plus 1. We are told that h of x has a finite limit as x approaches negative 1, and that h of negative 1 equals 0. Since the denominator becomes 0 at x equals negative 1, the only way for h of x to have a finite limit is for g of x to also go to 0 at the same time. And not just any 0, it has to cancel the singularity caused by the denominator. If g of x contains only one factor of x plus 1, then h of x simplifies to q of x for x not equal to negative 1. That means the limit of h of x as x approaches negative 1 is just q of negative 1, which could be any number, not necessarily 0. But we are told that h of negative 1 equals 0. So for the limit and the function value to match, g of x must contain at least two factors of x plus 1. That way, after canceling one factor with the denominator, the expression still goes to 0. Case 2. Now let's look at the second case. Here, h of x equals the absolute value of g of x divided by x plus 1. We are told that h of x is continuous at x equals negative 1. This time, we cannot rely on the signs canceling out like before, because the absolute value removes all sign information. Suppose g of x has only one factor of x plus 1. Then near x equals negative 1, g of x behaves like x plus 1. So the absolute value of g of x behaves like the absolute value of x plus 1. So h of x becomes the absolute value of x plus 1 divided by x plus 1. That equals 1 when x is greater than negative 1, and negative 1 when x is less than negative 1. This is a jump discontinuity because the left-hand and right-hand limits do not match. So once again, one factor of x plus 1 is not enough. To remove the discontinuity, g of x must go to 0 faster than x plus 1. This means g of x must contain at least two factors of x plus 1. In that case, the absolute value of g of x behaves like the square of x plus 1, and h of x simplifies to x plus 1, which approaches 0 continuously as x goes to negative 1. In both cases, g of x must contain at least the factor x plus 1 squared. In order for h of x to either have a finite limit or be continuous at x equals negative 1, that is why the final answer is x plus 1 squared.